Hey, welcome back. I'm Kelly from Signature Solar. Today we're learning all about the 48-volt Ethos battery by BigBattery. This stackable UL certified powerhouse is designed to bring exceptional reliability and efficiency to both residential and commercial spaces. Perfect for a wide range of applications including grid-tied homes, off-grid setups, and emergency supplies. The Ethos battery is all about safety, longevity, and superior performance. Whether you're exploring solar energy for the first time or aiming to upgrade your system, you're in the right place. The Ethos battery stands out for its intelligent energy management made possible by its advanced battery management system and lithium iron phosphate chemistry. This setup is not only UL certified to 9540A, ensuring the highest safety standards, including built-in fire suppression in each module, but it's also incredibly user-friendly for installation. Its modular stackability and the use of standardized Amphenol UL ESS connectors mean connections are both quick and secure, perfect for integrating into larger power systems. Plus, its grid-tied and off-grid capabilities, along with closed-loop communication with specific inverters, like the EG4 18kPV that we're installing today, offer flexibility for various energy needs, and every unit comes with a reassuring 10-year warranty. Setting up your Ethos system is remarkably straightforward. Once you position your rack base, all it takes is connecting the battery modules effortlessly thanks to the intuitive design and standardized connectors. Each module's unique ID ensures a hassle-free setup. Selecting your inverter's communication protocol via the controller box finalizes the integration. The easy-to-follow process ensures your system is operational in no time, showcasing the Ethos battery's convenience and efficiency. Today, we'll show you just how easy this process is as we showcase an Ethos controller box along with 6 battery modules, each providing a 5.12 kilowatt-hour of energy for a comprehensive demonstration of a 30.72 kilowatt-hour energy storage system. In addition, we also have an extra battery rack base, which we will need for our second stack of batteries, as well as extra cables for paralleling our second stack. Let's open the controller box first. You'll be able to tell the difference simply by the weight difference. It will be the lightest one of the bigger boxes. Look how nicely it is packaged, designed to guarantee the safe arrival of your components, which have been perfectly tailored to meet the specifications of your selected system size. You'll see what I mean as we dive in deeper. The first thing you'll see is the Ethos controller box and the base. Before we pull out these big items, let's take a look at the cables that come included in this box. Take note that each of these cables are designed to go straight from the controller to the inverter. First, we have the controller to the inverter communication cable. Notice the plain RJ45 connector on this end will go straight into the communications port in your inverter, and the other end will screw securely into the communications port of the controller box. So just a little side note here, one of our tech support associates was very excited about this little cable right here. This excitement all boiled down to this little innovation right here. This screw-in connector, because so many calls they receive, are because of this simple loose connection. This screw-in connector enveloping the RJ45 ensures that a good connection is made. So if you should ever have a need to remove your communication cable, we'll unscrew this connector. And it's really hard to see your tab in there, but your tab should be towards the front. I'll just take a small flathead screwdriver, and I'll press it in the front to release that plastic tab on the RJ45 connector and slightly pull, and we have not damaged our cable. If you just try to pull without releasing that tab, you will damage your cable. Next, we have 2 sets of controller to inverter power cables for a total of 4 cables. 2 positive, the red, and 2 negative, black. We know that these go to the inverter because they have one quick connect end with the Amphenol connector and one end with just insulation that will have to be stripped to expose the bare wires to be inserted into the inverter. Here we have our battery rack base. Notice the rubber stoppers. This will line everything up, keeping things secure as they stack. And last, we have our controller box. This comes with the nice covers already installed on the outside, which can be a bit tricky to remove. They just slide in and snap closed, so we'll take a small flathead screwdriver to help release the snaps so that we can remove the covers and see the inside. On the right side, we see our battery terminals and our battery breaker, which we'll talk more about later when we begin our installation process. On the left side, you'll find our power ports designed for seamless connection to the inverter alongside our communication ports that facilitate closed-loop communications, ensuring synchronized operation between the batteries and inverter. Additionally, there's a grounding screw provided for enhanced system safety. Front and center, we're greeted by the BMS LCD display alongside user-friendly control buttons complemented by the sleek ETHOS logo by BigBattery, embodying a clean and modern design. We'll explore these features later as we guide you through commissioning the batteries, ensuring they communicate flawlessly with the inverter. Next, let's open the battery module. It's the heavy one. These batteries weigh about 114 pounds, so be prepared to have a friend on hand to help out if needed. When you open the box, the first thing you'll notice is the thick foam padding that's there to keep everything well protected during shipping, making sure it all gets to you in one piece. In the center, you'll find a bag with stainless steel screws, drywall anchors, and L brackets for mounting your battery securely to the wall. There's also two 12-inch battery-to-battery parallel cables with quick connect Amphenol connectors on both ends, along with an 8-inch communication cable. These cables found inside your battery module boxes are specifically made for connecting your batteries in parallel. Once you take out the foam, you'll see the battery modules have sturdy handles near the top under the battery covers. These covers are just held on by one screw. The easiest way to deal with this is to stand the battery up in the box using the handles, remove the screw, slide off the cover, and put it to the side. After you've set everything up, you'll put the ETHOS side covers back on to give it a sleek, clean look, hiding all the wires. Each battery module has a capacity of 5.12 kilowatt hours and comes with an IP65 rating, ensuring it's protected against moisture and dust. The rubber points you'll see are designed for alignment, allowing additional modules to be stacked neatly on top. You can easily see how this works by looking at the bottom of the controller box. On the right side at the bottom, you'll find the positive and negative input terminal leads, while the top houses the positive and negative output terminal leads. Additionally, each unit is equipped with a built-in 125 amp DC breaker for added safety and protection. On the opposite side, you'll find the communication ports with the input, again located at the bottom, and the output located at the top. Just above these, there's a ground screw and the LED state of charge indicator for easy monitoring. Below that is the power button. And if you unscrew this area, you'll uncover the ID switches essential for configuration. Additionally, there's another ground screw at the bottom side for extra grounding options. Inside this longer box, you'll discover the additional rack base designated for our second stack of batteries. And moving on to our final box, it contains our extra cables for connecting our stacks. Here we have two sets of 4.9-foot battery cables, each equipped with Amphenol connectors on both ends intended for paralleling our two stacks of batteries. Additionally, there's a 4.9-foot communications cable included. The installation is designed to be quick and easy, so let's get started. So we'll begin by placing the bottom base on the floor, ensuring it's about 1.2 inches away from the wall. The rubber stoppers on the base are designed to support and align your battery modules as you stack them. Position the base so that the stoppers, which are closer to the edge, face the front. Next, grab one of your batteries, place it on top of the bottom base, ensuring it sits securely on the rubber mounts. Continue stacking battery modules on the top of the base, adding up to 3 in total. Once these are in place, position the controller box on top. Use the L brackets and mounting screws provided in each battery module box to securely fasten each module to the wall. Ensure that at least one side of the battery stack is anchored into a wall stud for stable support. The combined weight of the 3 batteries and the controller box totals approximately 387 pounds. The L brackets will be fastened right here between the modules. They offer some placement for flexibility, so for the best stability, I recommend using a level to ensure everything is as vertically aligned as possible. We'll install the L brackets on both sides of our stack to make this as secure as possible. Your total height for the 3 battery stack with the controller box on top is about 59 3/4 inches with a width of 26.5 inches and 6 3/4 inches deep. We'll hold off on setting up our second stack of batteries for the moment. With our first stack now securely mounted to the wall, let's move forward with connecting our battery cables on the right-hand side. First, remove the protective caps. Start by connecting the red cables to the B positive terminals and the black cables to the B negative terminals. Using the 12-inch cables provided in your battery box, initiate the parallel connections from the bottom terminal of the controller box. Connect the cable from this bottom terminal to the top terminal of the first battery module, ensuring positive to positive and negative to negative connections, and carefully route the cable behind the battery handle for a neat setup. Press firmly until you hear a click indicating a secure connection. It's wise to give a gentle tug on the cable to confirm it's properly connected. Continue this process connecting from one battery module to the next down to the bottom of the stack. Upon reaching the bottom, we'll explore some alternative configuration options. When you reach the bottom battery module, it's crucial to ensure the efficient distribution of the 200 amp current. This means creating 2 distinct paths for current flow, which not only maximizes equalization, but also reduces heat accumulation in the cables. Achieve this by looping the cables back to the top from both sides, carefully routing them under each handle. This technique is effective for both the 10 kilowatt-hour setup with 2 battery modules and the 15 kilowatt-hour configuration with 3 modules. Completing this step allows you to neatly install the covers, presenting a sleek and compact backup system. For those of you looking to construct a more extensive system, perhaps for whole home backup or extended periods of autonomy, we're prepared to take it further. The ETHOS systems are designed for scalability, allowing for the parallel connection of up to 16 batteries per controller box. Today, we'll demonstrate this by linking another set of 3 modules, bringing our total to 6 batteries for a robust 30 kilowatt-hour energy solution. We're going to remove these covers and use these longer battery cables to connect in parallel to our next stack. So let's go ahead and build our second stack of 3 batteries. BigBattery recommends maintaining a 12-inch gap between each ETHOS battery stack, as well as a 12-inch distance between the controller box and the inverter. This recommendation serves dual purposes. First, it ensures optimal airflow and heat dissipation among your batteries, essential for maintaining their efficiency and longevity. Secondly, the communication and battery cables are designed with this specific spacing in mind. Setting them too far apart might mean the cables won't reach, while placing them too closely could compromise airflow, causing the batteries to overheat and reducing their operational efficiency and overall health. Due to the constraints of our setup today, we'll ensure there's a 12-inch gap between our battery stacks, highlighting the importance of spacing for optimal cable management. This will demonstrate the ideal distance relative to cable lengths. However, please note that the inverter is positioned closer than recommended at about half the advised distance for the purposes of this demonstration. To make sure we have the appropriate spacing, I'll first measure 12 inches from the outside of my first base to the inside of the second base, leaving about a 1.2-inch gap from the wall. Next, I'll stack my first battery module securely on the rack and run my battery cables behind the base to make sure they will reach the terminals before I use the L brackets to secure them to the wall. Once I know the cables will reach, I can continue to stack the other 2 battery modules on top. Once aligned, we'll ensure they're firmly attached to the wall using the L brackets, just as we did with the first stack. Now notice, rather than extending the cables from the bottom to the top within a single stack, we'll connect them from the bottom battery terminals of our first stack directly to the bottom battery terminals of our next stack, ensuring red cables attached to positive terminals and black cables to negative ones. We'll mirror the daisy chain connections up the stack just as we did with the first using our battery cables. Upon reaching the top, we'll extend the cables from the top terminals of the second stack back to the top terminals of the first stack, thus completing our parallel circuit configuration. With our batteries now connected in parallel, let's tackle the communication cables. On the left side of our controller box, you'll find a communication port labeled battery. Open this port as well as COM port 1 on the first battery module and plug in our communications cable into both, screwing them in until they are snug. Then move down to COM port 2 on the first battery module, Connect the next communication cable from COM port 2 to COM port 1 on the second battery module and continue in this manner. When reaching COM port 2 on the last battery module, we'll need the longer communications cable from our extra cables kit to connect to COM port 2 on our second battery stack. Continue daisy chaining them up to the top battery module of the second stack. This setup ensures all modules can communicate seamlessly in a closed loop system. Now it's time to link our controller box with the inverter. Grab the longer communication cable, which has a standard RJ45 connector on one end and a screw-in connector on the other. Attach the screw-in connector to the control box on the left side where it's marked inverter, tightening it until secure. Then take the RJ45 in and connect it to the inverter. For the EG4 18kPV, you'll find the appropriate communication port located at the top left corner of the board, clearly labeled battery communication. Moving on to the power cables. These longer battery cables feature Amphenol connectors on one end and are insulated at the other. The insulated ends will need to be carefully stripped back about 3/4 inches before being inserted into the inverter. Once in place, they should be torqued down according to the inverter specifications, which is 165 inch-pounds for this 18K. We'll be using 2 sets of these cables because they're rated for 200 amps. This ensures our system is safeguarded against any surges that exceed 200 amps. Next up, it's crucial to assign the correct ID addresses to each battery module. You'll find the ID descriptions detailed in the manual on page 16, and it's important to pay close attention to these. While the functional order from top to bottom isn't critical as long as each battery has a unique ID, for troubleshooting purposes, it's wise to organize them in a manner that makes sense. BigBattery suggests labeling each stack in descending order, beginning with the controller box at the top. This methodical approach facilitates easier identification and management of your battery modules. I will start with the battery closest to the controller box and give it ID 1, down, 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 up. The next battery below that will give ID 2, down, down, up, down. Then the bottom one will get ID 3, down, down, up, up. Starting at the top of our next stack, ID 4, down, up, down, down. Then ID 5, down, up, down, up. And the last one will be ID 6, down, up, down. If you don't need the batteries to communicate with the inverter, you can simply connect them directly and select either lead acid or a user-defined configuration on the inverter. However, for optimal performance, we're aiming for closed-loop communication between our batteries and the inverter. This requires configuring communication protocols on the controller box, ensuring it knows exactly how to communicate with the inverter. Before proceeding, it's essential to verify your inverter's compatibility and the specific communication protocols it utilizes. This can usually be found in your specific inverter's manual. The 18K, for instance, supports both RS-485 and CAN protocols. Let's go ahead and set up these communication protocols now. To set up our communication protocols, general startup procedure will be to turn on our battery breakers on our inverter, then we'll flip our battery breakers on our batteries, and then we'll push our power buttons on for our BMS, and then we'll start looking at our LCD screen. Start by pressing any button located under the LCD screen on the controller box to activate the screen. The initial splash screen displays several crucial details, including the date, time, battery ID, current status, capacity, voltage, and the communication protocols. We're about to configure these settings, and you'll notice these details update in real time. Next, hit the back button to navigate to the About screen. Here you'll find information on the currently selected RS-485 CAN protocol, as well as the current versions of the BMS and screen firmware. After reviewing, press Enter to return to the main screen. Press and hold the back button for approximately 5 seconds, then release it to access the protocol setting menu. Once there, utilize the up and down buttons to move through the options within the protocol setting menu. When you've highlighted your choice, press Enter to select and enter either the RS-485 or CAN protocol menu, depending on your setup needs. We are actually going to set up both for the 18K. Use the up and down buttons to navigate the RS-485 CAN protocol menus and press Enter to select the highlighted protocol. The display will then return to the previous screen. We will go down and select Lux EG4 on the RS-485, press enter, then go into the CAN protocol and select Lux EG4 and press enter as well. This is only necessary to do once based on the way your inverter communicates. However, since we know that the Lux EG4 inverter can communicate using both RS-485 and CAN, BigBattery recommends going ahead and setting up both communications because it is easy to do and it will transmit both. In this way, it becomes a built-in fail-safe in case firmware updates or inverter settings can get messed up somewhere down the line. Once the proper protocol has been selected, press back and then power off each battery module using the power button and then power them back on. Once this is done, the selected protocol will save once the controller box is turned back on. We can now see the proper settings displayed on the screen. So far, we've not touched on the subject of the grounding screws. BigBattery has prioritized safety by incorporating grounding screws into each module. It's interesting to note that according to the National Electric Code, grounding isn't required for DC systems operating below 60 volts. So for these 48-volt batteries, grounding remains an optional but recommended safety measure. If you decide to ground your system, it's advised to use an electrical grounding conductor to link the battery modules together by connecting from one grounding screw to another in a daisy chain fashion, much like the rest of the cabling, passing through the controller box and ultimately attaching from the controller box to the protective earth bus bar in the inverter. This method is a proactive step towards ensuring your system's safety. While your inverter will manage and utilize the full capacity of your battery bank, if you're interested in monitoring each battery on an individual basis, you have the option to use the BMS Tools software included. This software allows for detailed monitoring of each battery's performance. For further details on how to leverage this software for battery monitoring, please refer to your manual. As you progress with commissioning your system and integrating your batteries with the chosen inverter, it's essential to consider several guidelines outlined in the manual. These are designed to ensure your batteries operate at peak efficiency and maintain their health over time. Here are some key tips to remember. Adhere strictly to the charge settings specified in the manual. The recommended voltage range for charging is between 55.6 to 57 volts. For LiFePO4 batteries, it's best to practice opportunity charging. This means charging your batteries whenever possible, but doing so in small increments. Avoid fast charging as it can reduce the overall lifespan of the battery. It's recommended to begin charging the battery when it reaches a minimum state of charge of 10 to 20%. While deep discharging doesn't negatively affect the battery's health, the battery management system needs a certain level of voltage to operate effectively. When it comes to discharging, even though the battery is capable of being fully discharged while maintaining constant power, limiting discharge to 80% depth of discharge can significantly extend the battery's lifespan, allowing for more than 6,000 cycles. With your system now fully connected and in seamless communication, the final step is to tidy everything up, ensuring your setup is not only safe, but also aesthetically pleasing. Begin by retrieving the screw previously set aside for safekeeping and remove it from the handle. Then, slide the cover into place until it clicks securely. The cover is resecured by inserting and tightening the screw back into the handle of the battery. Once all covers are correctly installed, your system will boast a sleek appearance. BigBattery has thoughtfully designed the side covers with notches to accommodate the cables stretching between stacks, ensuring your setup remains organized and visually appealing. The ETHOS battery isn't just a beauty, it's a powerhouse, a testament to sustainable energy solutions. Engineered for longevity, it supports up to 6,000 cycles at 80% depth of discharge under a 10-year warranty. Its intelligent BMS and LED interface provide continuous monitoring and health status, ensuring your system operates at peak performance. With the ETHOS battery by BigBattery paired with the EG4 18kPV inverter, you're equipped with a scalable, reliable, and aesthetically pleasing energy solution. This system not only powers your space, but also aligns with a sustainable future. Dive into solar energy with confidence, backed by a robust system and our support. Stay connected with Signature Solar for more product features, installation guides, and solar energy insights. Don't forget to subscribe to stay updated. I'm Kelly with Signature Solar, where we believe solar is for everyone. See you next time.